All right, I will be showing you guys our components for our combination system one by one, just so you're aware of how the system is put together. As you can see on the left here, we have our FSR sensor. This is a pressure sensor, so when pushed, it will actually begin initiating the system as well as with the pulse sensor. Right here, you have the temperature sensor. The temperature sensor will monitor the environment and, of course, give the temperature. And if it detects something outside the range that we give it, then it will register on our output. Right here, you have our pulse sensor with the finger holder. Whenever you're seated in the vehicle, this will, of course, be put on the finger and be able to accurately read your pulse in real time. And this LED connected to a 1K resistor will show that when we begin the experimental phase. This is the UV sensor, so this will detect the light coming in through the window ideally and be able to register onto the app whether or not it is harmful to the person seated in that location. This will be the 9-volt battery that will be supplying this microcontroller. We actually started out with 2 microcontrollers. We have reduced it down to 1 using the Arduino Mega instead of 2 Arduino Uno Wi-Fis. This has reduced our power consumption and created a more maintainable system structure. It's not 2 cascading systems, so we have less delay and less input troubles. As you look right here, this is actually the Bluetooth transceiver for the app. So any information that our temperature sensor, UV, pressure sensor, the stuff that registers in this microcontroller and monitors will output onto the app on the mobile device that our group is using. And that sums up our components. The only thing I didn't mention is the 10K resistor that is hooked up with the pressure sensors. So this is just the throttle ampage and basically make sure that we're getting accurate sensors reading.
So now we'll begin the actual demo video. As I plug the power in, my lovely assistant Victor will explain how we connect to the app. So this app can be installed into any Android device. Victor? So all you need to do is connect by Bluetooth to the transceiver, and then once the sensors are ready to go, as long as someone's butt is in the seat, it will begin recording all of our sensor values. So my pulse is a little high, so for a child this would be considered extreme situations, but otherwise, it is recording perfectly well. As you can see on the LED, it is matching my pulse as of right now. So if we start to increase the temperature, we will see that the heat does rise on our sensor. And then once we put a UV light to the UV sensor, we can see that raises just by a small amount, considering that this is just a very basic UV flashlight. You will see more extreme increases once we go outside and depending on the day. And then as said, these are all of our sensors, and it seems to be recording perfectly to the app.
Hello, today I will be discussing the IEEE Code of Ethics. To start off, the 7.8 IEEE Code of Ethics is always held in mind during our meetings, particularly where it concerns maintaining public safety with our system, especially since our system deals with child safety along with making sure that we are following Texas laws. Standard IEEE 488 says, number of devices that are interconnected should not exceed 15. As you can see, we do not exceed 15. IEEE 11842006 says careful installation and testing of a battery system for an uninterruptible power supply.
ISO 9001-2015 seeks our quality by making a system that meets customer needs and satisfaction. ISO 31000-2018 monitors risks and provides guidelines to manage any risks that could be faced. For ISO 45001-2020 deals with the timing and synchronization for time-sensitive applications. And then for IEEE 1522-2004 seeks to help with testing and diagnosing the system. We did it with our system as well. For IEEE 1413, 2010, it focuses on the reliable predictions of electronic hardware.